Hello, my name is Stephen Kalapaka, and today I will be giving a demonstration on how to use the tool TRACERT or traceroute. So traceroute is a network diagnostic tool, and it is used to map the path that a packet takes in order to reach its destination host. And so traceroute is going to work by increasing the time to live, or TTL for short, values, and then listening for ICMP responses from each hop along the way. And so I'm using traceroute in a Windows environment, and it's going to be slightly different from a Linux environment. So in Windows, traceroute is going to use ICMP echo requests, while in Linux, it's going to use UDP packets. And different firewalls might have different policies, like they might let the ICMP echo requests through, but not the UDP packets, or vice versa. So you just have to be careful with that and see which one's best for you. And so we run traceroute from the command line, and it's going to display the address of each hop along with its response times. So we can do a traceroute now, and I'll just do it to my home router, so it's a little bit of a shorter one. So we're going to type in trace and then RT, and then you can do an IP address. So we'll do the IP address of my default gateway, and we'll hit enter, and we'll see the first hop, and that's denoted by the 1 here. And then we have these 3 different times. And so traceroute actually sends 3 different echo requests. So these are the times of the 3 requests right here. And then we have the host name, which is router home local. And then we have the IP address of the device. And so we can try a little bit of a longer one now. And so we can type in trace route here, and then we'll do the IP address of, let's do a DNS server. So we'll see where this goes. So we can enter. Okay, and the traceroute is finished, and we can see it did reach the DNS server that we're looking for at this IP address. And we can see that it took a total of 12 hops here to get there. And then on the right, these are all the devices that it went through. So we can see the increase of the TTL values on the left here. So it goes from 1 to 12. And each time this TTL expires, a router is going to send back a response. And this allows us to identify every device that the packet passes through. So for this first packet, the TTL was set to 1. It got to the home router, and the router decreased it to 0. And since it's at 0, then the router sends a response back to our machine. And this is how we get the device name and the IP address. And that's how all these are going to work. So the TTL for this first one was 1. The TTL for the second one was 2. So this TTL being 2 means once it got to this first router, it got decreased by 1. So it was set to 1. And then once it got to this IP address, it was decremented by 1 again, which made it 0, which this device then sent a reply back to my machine. And we can see the IP address here. And that basically continues all the way down to 12 here. And now we can look at this line here. So we have the third hop, and we see asterisks on the time, and then it says request timed out. So this means that the traceroute didn't actually receive a reply from that hop within the timeout period. And so each hop normally it sends back an ICMP response, but some routers are configured to block these requests for security reasons or some other reason. So seeing the asterisk doesn't necessarily mean that something is broken. It just means the device isn't responding. And yeah, we can see since the trace continues after this, the packets are definitely still moving. And traceroute is going to work with host names. So if I wanted to do a traceroute and then I wanted to go to www.google.com, you can do that. All right, and the traceroute is complete, and we can see that it worked the same exact way as if you were to use the IP address here. So we use the fully qualified domain name here, and that just gets resolved to an IP address, and then it's going to trace the route to this IP address. So we can see same router, same first hop, and then another timeout on this third hop, and that goes all the way down to hop number 10, and this is the IP address we were looking for. And we can actually see some interesting things too. With the time values, we can see that they definitely increases time as they go along. So we could see first one is 1 to 2 milliseconds. The second one, that one's an outlier, be about 8 milliseconds for the second one. And then 4 milliseconds, 5 milliseconds, and then we see a hop up to 15, 17, around that area. And so as we move further geographically or across networks, the latency usually increases. So that's why we see the longer times here. And you also might see different routes that the packet takes, and this is just because, the path isn't always the same, and networks can, dynamically route traffic and send it different ways. And so there actually are a number of flags or options that we can use with the traceroute command. We could start with the -d command. So we could do tracer -d, and then we'll just do the IP address of the Google DNS server. And so the -d basically tells traceroute not to resolve IP addresses to host names. And this actually makes the command run a lot faster since it will skip the DNS lookup. And we can see that here. So for this first IP address, this is my default gateway, but it's not going to say router.local.home. And this last hop, this is the Google DNS server. It doesn't say google.dns like the other ones did. And then we also have the -h option, which is going to let us set the number of maximum hops. So we could just do traceroute.h, and then we could just put an arbitrary number here. We could do 15, and we could just send it to the DNS server again. And so this is useful if you want to, limit the amount of hops that your packets take. So it's only going to reach a maximum of 15 hops, and it won't go any further than that. And so it's complete, and it was under 15 hops, so that didn't really change anything. And we can actually try it with a smaller hop count too. So we could do traceroute, we could do -h, and then we'll just set it to 3 hops. And then we'll also turn off DNS lookup, and we could set it to that IP address again. We could start. We could see maximum of 3 hops here, and it should stop on this third hop here, and it won't go any further. All right, and there we go. And the trace is complete, and it stopped at 3 hops. All right, and we could talk about the -w option now, and this is basically going to set the timeout in milliseconds for each reply. So we could type traceroute, we can set the -w command, and we can set it to maybe, 5 milliseconds. We can do no DNS lookup, and then we'll just do the IP address of that DNS server. We can hit start. All right, and the trace is complete, and we can see we got responses back from all of the devices. All right, and that is going to be the end of the tutorial. And so in this tutorial, we explored how traceroute works and how it helps us to visualize the path that the packets take throughout a network. And so overall, traceroute is a really simple tool, but it is very powerful in that it lets you, understand network behavior and also troubleshoot network connectivity issues. And thank you for watching, and that's going to do it.